Okay, cool. Let's get started. It's a little bit after 10. So welcome to our webinar. This is Prioritizing Transit with the Collaborative Data Approach. I am one of the hosts. My name is Amanjit Ane. I am a Partner Success Manager at Remix by VIA. And then we have a very special guest, Nadia Barrera-Ramirez, who is with CapMetro. And then I'll give a little bit about her background in just a second. So before we begin, a few housekeeping items. I know we're about 15 months into the pandemic, so by now we're all Zoom experts. But just to quickly recap, you can use the Q&A to ask us a question anytime throughout the webinar. I prefer to use the Q&A instead of the chat function, just so that we can keep track of your questions and get them answered. And then during the Q&A at the end, you can always raise your hand if you want to be unmuted and ask your question in person. You can also use the chat function to chat with your colleagues, leave comments, share thoughts. And then just a quick heads up that the webinar is being recorded and we will send the recording out to all registrants. So that's something to look out for. Okay, cool. So now I'm super excited to actually dive into the webinar. When it comes to transit, what is a collaborative data approach? So a collaborative data approach encourages open data standards, a willingness to share data to minimize vendor lock-in, making the data easy and accessible within and across teams, and also making the data easy to visualize and analyze so that we can quickly pull key insights. Oops, skipped a slide. Let me go back one. Okay, so that's exactly what Remix and Swiftly were working toward when we started this partnership together. So this partnership means that you can now visualize Swiftly's historical speed and dwell time data in Remix to help identify challenge areas, areas of investment, and ultimately prioritize transit and improve speed and reliability within your region. The federal government has also prioritized this work in response to COVID-19 and the restoration of transit services. ARP funding is available for route planning designed to increase ridership and reduce travel times, as well as to make service adjustments to increase the quality of service in select neighborhoods. So always like to bring up grant opportunities, just because I know that as a transit planner, we're always looking for different funding sources that are available. So now super excited to introduce our very special guest speaker, Nadia Barrera-Ramirez. She manages cross-agency transit and mobility programs at CapMetro, where she started the Transit Speed and Reliability Program in 2018. Since launching the Transit Speed and Reliability Program, CapMetro has tripled its number of transit priority lanes in the network and optimized over 1% of their total bus stops. So pause, absolutely amazing. What a great accomplishment. She's a native Austinite. Nadia is passionate about working with partner agencies and stakeholders to provide high quality and sustainable transportation options to Austin's residents and visitors. So with that, I'll pause here and I'll let Nadia take it away. And then you can go ahead and share your screen, Nadia.
Okay. Let's see, whoop, you're not seeing it. Now you can see it, sorry. Hi, everyone. I just want to say thank you for having me. This is such a great opportunity to share what we've been working on here in Austin, and a special shout out to the Remix and the Swiftly crew of ladies that I've been working with to get this presentation together. It's been a lot of fun so far, and I'm excited to share what we've been working on. So I am Nadia Barrera-Ramirez, and I work for CapMetro. And quickly, I'm just going to talk about kind of Austin, Texas, and give you an overview and set the stage with kind of what we're working with here in our region. And then talk a little bit about the history of collaboration with the city of Austin that has led us to get to the point where we are today, and some of the transit priority projects and the types of projects that we work on. And then I'm going to specifically dive into East Riverside Drive and that project and some of the lessons learned from that. So Austin is one of the fastest growing cities in the country. We're the 11th largest. We are in a Southern conservative state, and we have a strong car culture. We also have a lot of single family zoning and not a very well connected grid network. So transit is kind of under invested so far in our city. And we really want to work towards kind of meeting the needs of our quick growth. However, we do have a strong economy and a very strong local culture. And so building on that and continuing to foster that growth is one of the things that we're working on. So CapMetro is our, I'm gonna minimize this, the public transit provider for the area. And we have everything from bike share to rail services. We serve over 30 million customers annually, over 535 square miles. And we have this recently voter approved investment that was approved back in November of 2020 that will allow us to really invest in transit for the region. So it includes everything from a downtown subway to improving park and rides and neighborhood circulators. And so the hope is that we will meet the needs of our fast growing city through this major investment. And we wouldn't be able to get the work done without our key partner, which is the City of Austin. So their transportation department is responsible for designing and constructing improvements in the right of way. And so we work very closely together to be able to do the work. So just a little bit of history. Back in 2015, the Transit Priority Working Group was created. And you can see a photo here on the left-hand side of folks from the Austin Transportation Department, as well as CapMetro. So staff, engineering and design, planners, and staff members from CapMetro and from the Transportation Department work together bi-monthly to carve out ways to prioritize transit and other modes throughout the network. And in 2018, we did a network redesign called Cap Remap. So looking at our entire suite of services, how could we make them more efficient? And we straightened out a lot of routes and did improvements to intersections, which required immediate and quick turnaround. So we dedicated $3 million for 3 years through an interlocal agreement in 2018. And that allowed us to kind of get the work done and work with the city and basically reimburse the city for that work that we were doing in the right of way. In 2020, a mobility bond was passed along with the transit referendum. And that mobility bond had a lot of funding for bicycles and pedestrians and urban trails, but it also carved out $14 million for transit enhancement, something the city had never done before. So allocating funds specifically for prioritizing transit through the right of way, which is very exciting. This year, we produced a Streets for Transit report, which I think we're going to put in the chat, but it basically quantifies and lays out all the improvements that have happened since 2018 so that we can kind of go back and reference those in the future. So some examples of transit priority projects that we do. In general, we are just improving speed, reliability, and safety for our customers. But also, since 2020, we started kind of thinking about the notion of improving customer access. So that means, how do we improve bicycle and pedestrian facilities to allow people just to get to the bus stop and to the train stop? So working on those as well. So some examples of spot improvements are low cost things like sometimes the bus can't make a turn, so we have to move the stop bar back or improve the curb radius, reconstruct a curb radius just to allow buses to get through intersections. So those are projects that we work on frequently. Bus stop improvements, sometimes the bus stop is in the wrong spot. It's mid-block or on the near side of the signal. So we prefer the stops to be far side for greater reliability and speed of the service. So we do a lot of those kind of small bus stop improvement projects throughout the city. But the big projects are the corridor improvements, and we're able to work with the city on their major capital improvement projects or even smaller bike lane projects, and that enable us over a large corridor to take a look at bus stop spacing, take a look at bus stop optimization, and really integrate the bicycles and pedestrian improvements with our bus stop improvements. So the example I'm going to talk about today, East Riverside Corridor, is one of these where we were able to take a holistic look at a corridor. So East Riverside Drive, just to set the stage a little bit, it connects the airport on the east side of Austin to downtown Austin. So it's a major corridor that connects two major destinations. It also has a major groceries chain on it, some pharmacies, a lot of commercial services, and multifamily uses. So there's big transit supportive density in the area. And for that reason, we have 9 different routes that serve the corridor, and those routes consistently carry 20% of our daily ridership. So it's a a big worker in our network, and even during the pandemic, it was carrying 20% of our ridership. So we noted that it was carrying a lot of passengers, and they're also experiencing a lot of delay during our peak periods. So we were able to identify the issues there. So the first thought was to install curbside, bus only, and right turn only lanes for this 2-mile corridor. We relocated a couple of bus stops and we closed some bus stops just to make the efficiency work a little bit better throughout the corridor. And the original projected travel time savings was about 5 minutes in the morning and 4 minutes in the afternoon. And so this chart shows basically it's automatic passenger count. So they're like lasers. For those of you that don't know, it's a automatic way to count people as they get on and off the buses. And so we took that data in the specific directions and different hours of the day. So the far left-hand side of this chart is the hours. So starting at 4 a.m. and it goes to 27. I'm not sure why it does that, but it does. And then different segments throughout the corridor from left to right is going from east to west, so going from the outskirts of town basically into downtown. And so you can see pretty clearly the passenger loads over time in that direction. And this data was taken from February of 2020. One of the things we noticed is that during the pandemic, we had less peak hour travel. So you can see kind of 6, 7 a.m., you're seeing a lot of passengers get on, but the peak doesn't really go away. It's still all the way until 4 p.m. We're seeing folks traveling in this direction. So that was of note for the transportation department to see that we're not dealing. It's an all-day issue basically. So let's see. The next thing that we used was Swiftly time travel analysis. So just looking at these visual representation is really easy for us to communicate to the transportation department and say, this is what the bus speeds are. It's kind of hard to see here, but it goes from as low as 9 miles an hour to 20 and above. And the yellow is about 11, 12 miles an hour. 12 miles an hour is our average speed that our buses travel. And so anything really around there or below there is an opportunity for us to make. So that's an easy way for us to communicate the amount of delay experience. So on the left-hand side here is AM speeds northbound, and on the right-hand side is the PM speeds for those peak hours. So after the project was put down and the markings were installed and we did the signage and all that stuff, we were consistently monitoring the project and noticed that there were still some issues, that the queues were very long at the signals, and we started to hear it from people in the neighborhood and the community. And we got emails like the ones to the left where people are saying, "This is the worst idea ever. It's totally inconvenient. It's not working. You've made Riverside a living hell," etc. So we were already kind of noticing that there were some issues, and we were able to identify that the cross street signalization was getting much more time than they needed. And so quickly we were able to get a signal engineer in the field to retime signals along the corridor, which I think is a lesson learned that, it's something that should happen right away. So on the right here, you can see a chart that shows the average travel time along the corridor, and this is for all traffic. The green bar is before, and the blue bar is after the transit priority lane went in without the signal retiming. And then the yellow bar is with the signal retiming. So you can see that between the green and the yellow, it's really a very small, maybe 1% difference in travel time. And that's all because of the signal retiming. And so the fact is that we could carve out that bus only lane and right turn only lane and not see a big difference in travel time for general traffic, which is a win for us. We did, however, notice that it's not as significant of a travel time savings as we initially thought, as the original models showed. So we're really only saving about a minute in each direction for the AM and PM peaks, but that's a 10% travel time savings, which is really good. We were able to do intercept surveys with customers that were riding the bus and waiting at the bus stop, and 85% of customers were happy with the new transit lanes, and 25% of them said that they're riding more frequently because of the travel benefits that they're seeing. So we also talked to some operators, and they did express some concern at first with because buses are traveling in that outside lane, and it's a very high commercial corridor. There's lots of driveways. So getting folks used to not pulling in front of the bus to then make a right turn. So I think as time has gone on and people are more used to the bus lanes being there, the way that folks are merging into that lane has gotten better over time. But operators did note that for those routes, because not all of them travel the entire corridor. So for those routes that are traveling the entire corridor, there was significant travel time savings for those folks. So just a couple of lessons learned. The first is that because we've had this longstanding relationship with the city of Austin, we know exactly what they want to see. And that is, the travel time data, the speed data, and the passenger and bus load data. So making sure that we have that information available from the beginning is helpful. And then, monitoring a project and being able to have staff that can go to the field and make those changes quickly when needed was really the key to the success of this project. And then finally, the holistic approach, where we looked at the entire corridor, looked at bus stop spacing, and looked at, we did do some resurfacing of the roadway to improve those conditions as well, I think was important for the project. And at the bottom, you can see a word cloud just taken from that intercept survey. So overall, I think it's a success, and happy to chat with you guys over any questions that you have.
Super cool. Thank you, Nadia. It's super, I love the word cloud at the end, but also really cool just to see how you've worked on a project. And then once you got all the feedback, you go back to the drawing board to see how you can make it even more successful. And then we'll hold a few questions to the end, but for now, I'm going to go ahead and stop sharing your screen. Let's see here. Boop, boop, boop. Oh, there you go. And then let me go ahead and share my screen really quick. Let's see. Just go over here and open my Remix screen up. Okay, cool. So before we jump into questions, I'm just going to quickly demo the integration just so that everybody can kind of get an idea of how it works. So the integration is accessible through a data layer. The data layer allows you to visualize the historical speed and dwell time data from Swiftly's speed map. So once you're in the platform, you can go ahead to your data layers. That's the bottom right-hand corner. And then what I'm going to do here is just actually search for it. So if you just type in Swiftly, I can easily click on it. And then you'll notice that this interface on the right-hand panel pops up. So what I'm going to do now is I'm going to choose a few lines that go around the downtown Austin area, as well as close to the university. And then I totally cheated and I looked at this beforehand. So that's why once I click on these lines, I don't have to ask. So I'm going to go ahead and choose the 20 and then the 801 and 803. And then you'll notice that as I'm clicking on these, they're just populating on the map. Very cool. So now, once I clicked on the lines, I can go ahead through the filtering. You can choose the direction of travel, inbound, outbound. I can choose the days of the week. So in this case, say that I only want to look at the weekdays, I can go ahead and do so. The date range is what I think is the most exciting. So Remix is fetching this data dynamically. So we can actually pull as recently as yesterday. In this case, I'm going to actually choose the last month. And then we're also able to do time of day. So you'll notice that once it loads up, when we choose the time of day, we can choose some pre-populated ones, or we can choose our own time, depending on how quickly you want to drill down. In my case, I'm just going to use the AM peak. So I'm going to select that and have it load up. And then once it loads, you'll notice that everything is color coordinated. So just like a stoplight, anything that you see in red is slow. And then as it moves to green, it's moving faster. So as I hover over a particular segment, I can see the route title, which is Route 5. And this is the average speed of 6.2. And as I move along, I can update those times.
Can I interject really quickly? I don't want to.
Sure. No, go ahead.
I use this all the time, and my favorite thing is that you can put all the different routes together. You can see them all in one place, and then I love the AM PM peak stuff. It's so useful. Anyway, thank you.
Love that. Exactly. So anything that you want to look at with the, well, I think it just gives you so many more possibilities because you're able to aggregate the data. And then one other thing that I really like, and Nadia, feel free to jump in, is you can actually see the dwell time for each of the stops. And then what I really like about it is that it's super visual. So if the dwell time is larger, the circle is larger. And then if the dwell time is not as long, the circle is significantly smaller. Cool. So the other thing that we can do here is we can actually click on a particular segment. And then once that segment is selected, you'll see all of the information on the left-hand side that we're pulling in from the Swiftly API. So we have the line that we selected, the average travel speed, the total length, the travel time, the number of trips. And then what I think is really helpful, just because the buffer is turned on, is we can also see the starting stop and the ending stop for that particular segment. And then like always in Remix, you can also see the demographic information at the bottom. You can star on or star off, whatever you want to look at. And then jumping even further into this, you can also adjust the buffer here on the right-hand side. So for example, say that I only wanted to look at a 1/4 mile. I could do that and my buffer is going to shrink. And then I really, oh my gosh, Nadia, I love you so much. I'm so glad that you're on this call with me. The other thing that we can do is we can start expanding the segment so that we can start aggregating the data. So we can do this in 2 ways. I can either hold my shift button on my keyboard, and as I'm clicking on it, you'll notice on the left-hand side of my screen, all of this information is aggregating. But if you're me and you want to find the quick and easy way to collect this information without having to individually select each line, you can also use this bulk select feature. And then I'm actually going to zoom out a little bit. And then you'll notice that it's going to tell me that if I hold down my shift button on my keyboard, I can actually add this to my selection. So I'm going to go ahead and do that. And then boom, I've looked at the entire corridor. And then again, the buffer is adjustable. So say, for example, I was trying to look at, let's say I was looking at transit signal priority and I wanted to move out of a 1/4 mile buffer and instead I wanted to look at 1 mile, I could always do that. Okay, so now what I think is even more fun, I'm going to close out of this. Okay, so say now I'm in a situation where I want to look at some key areas where I want to make some service changes. So in the beginning of this presentation, I briefly touched on the ARP funding and looking at low income or I think it was, yeah, low income communities. So what I'm going to do is I'm going to leverage my Swiftly speed data. So now I'm going to open up another layer. So I'm going to go ahead in my layer panel. I'm going to go to my poverty layer. And then I'm going to overlay both of them together so I can see both. I'm going to quickly rescale this so that my data matches up a little better. And then now what I can do is if I go ahead and click this bulk select feature on the right-hand side, I can start drilling into areas that look interesting to me. So in this case, like just taking a look at this map, this area here seems pretty interesting because it looks like there is at least some portion that's living in poverty. So what I can do is I'm going to bulk select. And then here is my magic moment. I'm going to go ahead and create this selection. And then super cool, on the left-hand side of the screen, I can see all of the lines along the selected segments. I can see Remix is going to take Remix is going to take all of the parameters we selected. So the time of day, the segment, the dates, and then doing a distance weighted average, we're going to be able to quickly summarize the speeds along that corridor. So you can see here that I can see now the average travel speed and then the total length. And then of course, At any time, if I wanted to do further analysis in Excel, I can always go ahead and export all of this information into an Excel file. And that's it. That's how easy it is to build transit performance into your planning workflow. And I'm going to quickly switch back to a different screen. Let's go down here. Okay, and then I was super excited, so I think I took a little bit of time. We have 3 minutes left for questions. So I'm going to go ahead and change this view back to present. And let's take a look at the questions.
And I see some in the chat that I can answer right away if you want. The speed data was from probably was September 2019. So we did prior to COVID speed data. We were communicating with the city. And the source is Swiftly data that we used. And I don't know, the projected speeds are hard. I don't have an answer for that.
And then it looks like there's one other question for you, Nadia. Did you have any friction with city traffic engineers chafing at transit priority when they're so used to focusing on moving as many cars as possible?
Yes. I mean, that's the point of having all that analysis, right? To say, you know, these are the number of people that are traveling on this corridor. It's very important. We're seeing it's a very high, you know, ridership corridor. And I think the big thing here was that it had 3 lanes of traffic on it, and the volume did not necessitate the need for 3 lanes. So I think they felt very comfortable removing or, you know, reappropriating that lane for transit and right turn only. And essentially like moving all those volume of buses out of other lanes, right? So it just is a reassignment in this case. I think what you're talking about, Hillary, is in other cases where it's much more, you only have maybe a couple of lanes of traffic in each direction, and there's a much higher level of volume of cars, then you start to go, you have to talk about balancing the needs a little bit more. But showing the number of passengers is always kind of what we've had a lot of luck with.
And then we have one question from Michael Abeg. So help me understand, the Remix Swiftly speed map is showing actual observed speeds from the Swiftly data set and not just predetermined speeds. Yes, that is correct. Let's see if there's any questions in the chat that we missed. What is the data source for the transit travel speed? That is coming from the Swiftly speed map. Let's see.
So there's something on the bus that pings Swiftly every 3 seconds, basically, that provides that data.
And then I'm just going to throw one of my own questions in because I was curious. So you mentioned that you closed 2 of the stops to improve some of the spacing. How did that go closing the stops? Was there any pushback on closing it?
No, I think we look at ridership first, right? And then we notify by putting signage on the bus stop. But I think we put them in more convenient locations, so and improve the existing stops.
Very cool. And then let's see here. Okay, cool. I think we are just at time, but I do see some other questions coming in. So let me just move forward with my slide. So the last question asked was, how do you get Swiftly speeds added? Is that an all-encompassing AP style system? Okay, so if you are a Remix customer, feel free to reach out to your Remix CSM and we will connect you to a Swiftly team member. And then also the opposite is true. So if you have a Swiftly membership and you don't have a Remix license, then reach out to your Swiftly CSM. And then if you don't have both and you just happen to find yourself on this webinar, I applaud you on your advocacy. And if that is the case, you can always drop something in the chat and we'll be happy to reach out to you. But yeah, thank you all for joining us. Nadia, you're amazing. I can keep singing your praises for the end of this webinar, but yeah, thank you everybody for joining us. And just a reminder that we will be sending you the recording shortly. Cool. Well, I hope everybody has a fantastic day.
Bye.
Okay, thank you.